Hello, welcome to the second episode of our Python tutorial using our Microbit. So in our first episode we had a look at writing some code which all it did was it created a list of points and then we filled that list with these individual points here, and then we created a function which went through all of these points and just printed them out onto our Microbit, turned them all on the LED matrix on the Microbit. The way that we did that was by referencing them using an X and a Y. So the point 0, 0 would be this one here. The point 2, 4 would be this one here. So we can use this grid system to actually turn LEDs on and off. Now the idea for the game is going to be that if, for example, we have showed our trail of those corners across to our user, all of that, then the user will have to start here and then press the B button, which will move them here, press the B button, move them here, B button, move them here, B button will move them here, and then start pressing the A button to go down, right? Now what's going to the lose condition of the game is going to be, say they go to here and then instead of pressing B to go right, they press A to go down, they're going to lose. I don't know what the lose condition is going to be yet or how the point system is going to work, but we'll work that out as we go along. Basically, they're going to have to follow the trail. If they don't follow the trail correctly, we're going to write a check-in to make sure that they are following that correctly, and if they're not, then they've lost the game and they'll stop gaining points. So how are we going to achieve this? We're going to, obviously with the code at the minute, the trail is always going to be straight across and straight down, straight across and straight down, doesn't require any memory. So what we're going to do this session is we're going to take our starting point and we're going to use our starting point and we're going to tend towards our finishing point. And the way we're going to do this is very simple. I've come up with a very basic algorithm for doing it. And what that algorithm is going to be is we are going to take the list that we have created in the first session. You remember this square bracket syntax, and then we had list objects inside of our list which had an X and a Y in there. That's very poorly drawn, I do apologise. But so we had an X and a Y value in each of these elements in those lists. So what we're going to do is we're going to write a function now. Remember, a function is something we can call over and over from within our code. And at the top of the function, we're going to have a call in which is actually going to delete all of the elements that's in this list. So it's going to empty the list. The list is going to start with nothing in it. I don't actually remember the function call for that in Python, but we'll have a quick lookup of it on Google before we start writing our code. So once we've cleared the list, we're going to take our starting point, which will be 0, 0. Sorry about my drawing skills, they're not that good. So I'm going to take this element 0, 0, the point, and we're going to put it inside the list, right? And then once we've done that, it's going to be very easy to generate our next value. And the reason it's going to be very easy to generate our next value is for us to go right, we have to take the starting point and we have to add a 1 on to the left hand side and a 0 onto the right hand side. Or alternatively, we add a 0 onto the left hand side and a 1 onto the right hand side, 0 to the X, 1 to the Y, which will move us down. Okay? Well, how are we going to do this? How are we going to get a switch which adds 1 to one of them and not to the other? Well, we're going to do it using, well, what I think is quite a cool piece of code. Oh, that's not going very well, is it? And what we're going to do is we're actually going to write some code that gets a random value that is either a 1 or a 0, and then we're going to add that value onto the X value of the previous point. Don't worry if that sounds complicated, it'll make more sense in a minute. So if we have our first point here as 0, 0, then I will generate a new random number. If that random number is 1, then I will add 1 to my X value, which, so if my X is 0, I'm adding 1 to it, meaning I'd be looking at this point here, right? And now we need to work out what the Y of this point needs to be. So are we going to move it down or not? Well, we've added 1 to the 0, so I know that I need to add a 0 onto the 0 so that we've just moved right. Otherwise, we'd always be moving diagonally, and we're going to get that same issue that the trail is going to be the same every single time. And also, we won't be providing our user with an ability to actually go diagonally. They can only go right and down. So here, we're actually causing them to not be able to play the game. So how are we going to do this? How are we going to make it so it's only added onto one or the other? Well, we're going to do it in a very simple fashion. What we're going to do is we're going to generate a new number, x, and it's going to be equal to 0. Actually, no, let's not call it x, that's just confusing. Let's call it z. And it's going to be equal to 0, or it's going to be equal to 1, right? And now we're going to add a new point to our list. So we could say list, for example. So our list in the last piece of code, I remember it was called trail, but in this case, just say list dot add. And we're going to add in, well, the x component of the previous point, and we're going to add z to that. Okay, so if in our code we've generated a 0 value for z, if the x of the previous point is 0, z is 0, then this here is going to actually be a 0. If z is equal to 1, then it's going to be a 0 plus a 1. So it's x plus 1, meaning this will be equal to 1. And then for the y, we're going to do y plus 1 minus z. Okay? And what this is going to do is, if z is equal to 0, then x plus 0, if x is 0, then you've got 0 plus 0 is 0. And if y is 0 as well and z is 0, then we've got 0 plus 1 minus 0. Now 1 minus 0 is 1, and 0 plus 1 is 1, so we'd end up with a 0 and a 1. Alternatively, if z is 1, then here 0 plus 1 is 1, whilst 0 plus 1 minus 1, well, 1 minus 1 is 0, and 0 plus 0 is 0. So now we have a way of being able to add that stuff up without worrying that we're going to be adding stuff on that's going to make us go diagonal. We can only add information onto one side or the other. We can't add onto both. And by doing that, we can only move right or we can move left. We can't do both of them at the same time and go down diagonally. So here's an issue. What if every single time we generate that number z, we get a 1? We're going to get over here, and then we generate again, and we've got a 1. Well, we can't go over here because we've gone off the grid. So what we're going to have to do is we're going to have to write something into this, which lets us check if the x value is equal to 4, then z is going to have to be equal to 0. Okay? And if the y value is equal to 4, then z is going to have to be equal to 0, to 1 or 0. Can't remember which way around it is. Basically, we're going to say if we're at the bottom, you're only allowed to go right. If you're at the far right, you're only allowed to go down. And this should be quite easy to do. Just while we're here, let me just fix this little bit of the grid because it's going to annoy me that it's not quite right. There we are. So that's what we're going to be doing this time. We're going to be writing an algorithm which allows us to create a new trail. So the first thing I'm going to do is comment this bit of code because I didn't do it last time. So let's say create the game loop, and then call the function to print out our trail onto the screen. Okay, and then we're going to sleep for, and I've just said here sleep for x because we're going to change this value as we go for different reasons. So basically what we're going to do now is I'm going to create a new function which allows us to generate a new trail. Okay, so this function is actually going to do all those things that we've just spoken about. So first, what do we want this to do? Well, the first thing we need to do is we need to clear trail. So once I've defined the function, so generate trail, and let's just quickly get onto Google and have a look what the function to clear a list in Python. And I think it is actually just a clear function. This actually removes the contents from the list, not replaces the old label with a new empty list. For the sake of completeness, slice assignment achieved say this effect. So so we're just gonna, we don't have Python 3.3, or do we? I don't know what we're actually using. So what we're going to do is we're going to just use that example that they gave, which was we're going to change the object that our list, that our trail variable is pointing to a new empty list. So the way they were doing that was by calling trail equals a new empty list. Now what that's doing is, what that'll look like in memory is we have let's say we have a variable trail, okay, and we set trail equal to this thing here, right, which means an empty list, right? What this actually does in memory is we create an object trail, and what this object is it's a variable pointer, and this is going to be pointing to a list in Python, and all this list is going to be is it's just going to be a new, it's going to be an object that's empty, okay? And then we might say let's add or append or whatever function, so we're going to put something into the list, right? So let's say we add 1 to the list. What this does is here we are then going to have a pointer to another point in memory which holds our value of 1. Okay? And then when we add something else in, I'm not sure exactly how Python works. I'm not sure whether it's referenced from here or from this one, because you've got different ways that this memory management can work. But as far as I'm aware, when you add something else into the list, this is the 0th element, and then if we add, again, if we call this .add and we put a 2 in there, then we would add a 2 in here, right? And this would be the first element, and we would have another arrow pointing to that, okay? Now, what this call here is doing, I'm not sure about this bit. I think that this is, I think what that does is it's deleting this reference, but I can't be sure about that. So I think that deletes this reference. But regardless of whether it does that or not, what this function call here is going to be doing, this call here, bit of code here is going to be doing, is it's going to get rid of this pointer so that trail is no longer pointing to that. It's going to create a new empty list, just like we've created in the original point, and it's that list is going to then point over down to here, right? So we've got a new empty list, and then if we call .add1, this same process would happen again, but it's happening on a new list. So this list is empty, it's fresh, and Python actually has something called a garbage collector, which runs through all of these bits of the code here, and when they've got nothing pointing to them, it will delete all of this memory. It will get rid of all of that. But to be fair, that was probably a bit more than you needed to know about it. All you really need to know is now we have an empty list. The list that we were using is gone. It's empty. We now have this empty list that we can start working with. Okay? Now, the first thing that we are now going to do is we are going to add the start point to the list. And what our start point is going to actually be is... no, let's not do it that way for now. We're just going to actually add in a new list, which holds the value 0, 0, which if you remember from up here, that is the first point that we're going to be looking at, so we now have 0, 0 appended into that list. Now we're going to go back to using loops. This time we're going to need a loop that runs, well, it's going to need to run 7 times. So we're going to need to add something new to the list 7 times. The reason for that is after we've run this loop, we're going to also add the endpoint to the list as well. So we're going to say trail.append for 4. Now if you remember from when we were counting before, we know that between here and here there's always going to be, well, 1, 2, 3, 4, 5, 6, 7 points. And if you remember from the last video, the way that a for loop works is it will go from whatever you set this first value to and count up in ones until you've reached whatever the second value is. In this case, this value is 9, so this will run from 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay? Now we need to actually run through these numbers 7 times, and the way we're going to do that is we're going to loop 7 times, and each time add a new element to the list, right? So for I in our range, and we're going to use the range of 0 to 7, and the reason we're going to do this is, well, we've got 0, 1, 2, 3, 4, 5, 6, and that is 1, 2, 3, 4, 5, 6, 7 numbers, so we're counting this 7 times even though we're actually only counting up to 7. So this loop runs 7 times. Inside of that loop we're going to want to create a random integer. The way we're going to do that is we need to come up here, let's get rid of this and let's just say import the Microbit libraries. And then we need to now import the random int function from random. So we're going to say from random import random int. Okay, and this is actually a function which is going to generate a random int for us. And the way that that works is we're going to generate a new integer randomly, and it's not actually randomly. Most computers use something called pseudo-random, which isn't actually true random, because it's based on the processor ticks. You don't need to know about this. Just know that for the purposes of this, it's random. It's working as a random number, and we're going to randomly generate a 1 or a 0. So we're going to get a number between 0 and 1. So it's inclusive. So this next call, we're going to say, well, Z was the number we used in our explanation before. So Z, our random number, is going to be equal to a new random int between the values of 0 and 1. And this, if I said 5, this would provide me with a value of Z that was either 0, 1, 2, 3, 4, or 5. So it's inclusive of this second number. Definitely be aware of that. I had quite a big bug in another piece of code I wrote last week where I'd forgotten that that was inclusive, and on the Microbit you can't actually debug very well because all of your debug and error information just gets printed out, scrolled on the screen. It takes a really long time, so it's really important to know what every little bit of code that you're writing is doing when you're writing for Microbit. If you don't understand it, you're going to really come into some issues because you're just not going to be able to get stuff running. I've no idea if this is going to run or not. If I do have to debug it, then you'll have to come along that process with me. That's sort of the idea of these videos. I've not built this before. We're building from scratch. I just want you guys to see the processes that I'd be going through when creating something new from scratch, and how I think about the ideas that I'm doing. Now what we're going to do is we're actually going to generate a new x and y based on whether we are going right or down, and then generate a new point, should I say, based on whether we are going right or down, add the new point to the list of points in the trail. And last video, if you remember, when we were doing this, I had a bit of an argument with myself actually about how I was going to do this. I wanted you guys to see I'm setting, when I print my trail, I'm turning these on and I'm getting the X value from this list, I'm getting the Y value from this list, turning it on, and then I'm moving on to the next one and getting the X value, the Y value, turning that on, getting the next list, taking the X value, then the Y value, and turning them on. This code's actually a bit surplus, we don't need this. When you're programming efficiently, you have to think about how expensive things are to do. In this case, I'm creating an X and a Y value that once we have gone back down out of here, that only exists here. As soon as we're out of this block, it no longer exists, this X and this Y, just like before when we talked about how memory works as a pointer. So your X value will be pointing to this value, and then when you come out of here, that's deleted. That's unnecessary, and it's extra processing time that we don't need to use. So we're going to replace this X just with the actual call to that specific element, and we're going to do the same with our Y. We're just going to replace it with the call, and then we can get rid of those two lines of code. And here we're actually just setting this pixel on, rather than setting it to a variable and then turning it on. It's just to speed our code up. It's kind of as long as it is short in terms of actually writing stuff. But if you're wanting to write code efficiently, these are the things you need to be thinking about, particularly with a game. A big part of game engineering is making sure that things run efficiently. So we're going to turn this pixel on, and in this bit of code here, we're not actually turning a pixel on, we are adding a new point to the existing list of points. And the way that we're going to do this is we're going to append. Append means add at the end. There is also an add function, so I could say something like trail.add a new list 0, 0, and I could say let's add it at the 0th element, that's going to add it at the beginning. If I say the 3rd element, that's going to add it at the 4th element. Remember about 0 index, so 3 is actually 4. But we're not going to be adding on anywhere in the middle. We want to add this onto the end because we want our trail to go in order. So I'm going to append onto this an X value and a Y value, and that's going to be generated as a list. And the first element in this list is going to be the previous. So remember, we've already added this first point to it. So when I look at the 0th, is the first element I'm going to look at because I is originally equal to 0. When I look at the 0th element in this list, it will be this here because the list is empty. There is only one element, so this is the 0th element. And what I'm going to do is I'm going to add on I'm going to get this value here, and I'm going to add Z to it. Remember before we discussed that adding Z to this, if I've got a 0, if Z is equal to 1, then this here will actually be equivalent to 1. And then for the second one, I want to take the other element in this list. So I've got this list called here, and then I'm getting this element with this call. So here I'm pointing at this 0, and I'm going to add to that the value of 1 minus Z. And remember we talked about that's going to get the reverse of Z. So if Z is 0, this is 1. If Z is 1, this is 0. And that's letting me go left or go right. We're going to add that list in, and that's it. That's all we're going to do. When I is equal to 0, we get this point. Then when I is equal to 1, this list here will have been added in, and that could have a value of 1, 0 or of 0, 1. We're not sure. And then when we come through again, I will be equal to 1, meaning we will get this object with this call. and we will get this object when we put this specificity into it. Okay? Don't worry if you don't fully understand this yet. I'm hoping it'll make a bit more sense when the code's actually run. But as far as I am aware, that should now work. I don't think there's anything wrong with that. I haven't actually tested this out before. As I've said, this is the first time I've written this stuff. So now let's call the function that will generate a new trail. And that is gen underscore trail. And then we're going to sleep the program for 2 seconds. Okay. Now, I'm just going to get my phone ready so I can video this for you when I plug my microbit in and run this for the first time. So let's go over and have a look at where that's saved then. So you can see the microbit is plugged in. I'm going to bob that over to the microbit. You should be able to see on your screen now a video of this. And what happens when this runs? Value error. Index out of bounds. Okay, so we've got our first error message there. You'll have seen on the screen quite how disgusting errors are to actually debug when you're writing stuff in here. And we can see immediately line 20 is here. And basically, what have we done? We've gone out of bounds with something. Do you know what? I think it's probably this call here that's done it. Let's try that. Okay, it isn't clearing anything in that list. Right. I think I've got a bit of an idea about what's going on here. At least I've got an idea of what we can do to get around it. So let's just say here, instead of appending this to it or clearing anything, all we're going to do is we're going to start at the first element and go to the 8th element, and we are going to, instead of this, we're going to set the value of our ith element equal to that of I minus 1 and I minus 1. So there's a bit of a difference here with what we're doing. We're not actually deleting anything in that list anymore. All we are doing instead is I am taking the first element, which is this, and I'm replacing it with this list. And we're adding a 1 either to here or here. So it's either going to be 1, 0 or 0, 1. And then the same again. So if this one is 1, 0, this one could be 1, 1 or 2, 0. Or alternatively, if this one is 0, 1, this one could be 1, 1 or 0, 2. So we've sort of randomized somewhat what we're doing. As I discussed before, memory management can be a little bit painful sometimes in Python. It's probably a good thing that we're actually going through this code so succinctly, one bit at a time. So let's have a look whether this works or not. I'm recording on my screen now. You should be able to see what's going on. Just uploading, and is it going to work? Okay, we got that one up. Yes. And now we've got another line 20 value error. And I'm fairly certain what's going on there. Is that it's going to be something to do with the fact that we have gone off the bottom of the screen. So we discussed before, we need to, if we're at the right, we need to go down the right, and if we're at the bottom, we need to only, if we're at the right, we need to only go down, and if we're at the bottom, we need to only go right. We don't actually have a check-in for that, so that's let it go off the screen. But we saw that it worked once, so I'm quite happy with that. I'm quite happy that it's working. I think what we'll do is we'll leave today's tutorial there. I know it's been quite long, and there's a slight gap in it as well because my screen recording stopped part way. It got a bit broken towards the end, I'll admit, but we got that bug fixed. A few bugs to go over next time, and I think what we'll probably do is I'm going to try and check what's causing that before we actually record for next time. But I hope you've enjoyed this tutorial, going through this second part, generating our own trail, and that you've learned a little bit about memory management. Thank you once again for tuning in, and I suppose I'll see you next time. There'll be a video here, a link to my next episode at some point, and over here you'll be able to see the previous video. So thank you very much for your time, and I'll see you next time. Cheers.